Hello everyone. So in the previous video, we saw how to do binary tree in order traversal with recursion. So in this video, we will try it out with iteration. So let's get started. So to do it in the iterative approach, we will iterate through the root, and in our stack, we will append the root values and we will iterate it through our left subtrees. So what will happen is, if I keep a record of the stack, so our stack would be, first it will be 1, in the next iteration it will be 2 1, then it will be 4 2 1, right? In the first iteration, in the next iteration it will be 4 2 1. So after we have reached this point, what we will do is, we will pop out that element from the stack, as it does not have any left subtree. So we will be kind of like appending it to our result array, because it does not have left subtree, and as our inorder is left, root, right, as it does not have a left subtree, so we will be appending our root value, and then we will check if it has a right subtree. So from here what will happen is, our 4 will get popped out. We will be left with 2 and 1, and as we are popping out the 4, what we will do is, we will append it to our result, right? So till here we are done. Now we are checking if our 4 has a right subtree. It has not got a right subtree. So now our root, is null, as it does not have a right subtree. So while our root is null, it will not enter this iteration. So what will happen is, it will pop out another element. So after we have popped out 4, it will now pop out 2, because we checked there is no right subtree to iterate through. So now what we will do is, we have written left, now we will write the root 1. So we will pop out 2, in the stack we will be left with 1, and we will append it to our result. So we have written left, then we have written right. Now we will iterate through our we have written left, we have written root. Now we will be iterating through our right subtree. So when we come here, now our root will be root dot right, which is 5. So as our root is 5, it will enter, as our root is 5, it will enter this iteration. So now our stack will be 5 1, right? But when we do root is root of left, we don't have a left, we have got null. So it will come out of this loop. Once it comes out of this loop, it will now pop. So from our stack, 5 will be popped, it will be appended here. As it will get appended here, now we will check if it has got, now we have completed, like the left is null, we have completed the root. Now we will check if it has got a right subtree. So has it got a right subtree? Yes. Now our root will be root of 6. So now this will go again into iteration. Now our stack will be 6. It will get appended to our stack. So 6 and 1. Now when we check, has it got left? No, it has got null. So if it is null, now our root is null. So it will just come out of this, of that loop, and we will pop that element out. So 6 will be popped out of here and 6 will get added here. So now we will check if it has got a right subtree, but it is also null. So our root is now null. When our root is null, it will not enter this iteration. As it will not enter that iteration, it will make another pop. So now it will pop 1. If it will pop 1, then it will append 1. Now what has happened is, as you will see here, mm, as you will see here, now we have completed our left. This was our left. Now when we are popping out the 1, we have written our root. Okay, so after we have popped out and we have appended it, now we will check if it has got a right subtree. So it has got a right subtree. Now we will put a 1 here. Sorry, as it has got a right subtree, here 3 will go. 3 is in the right. So 3 will go. Now 3 will go here, and when it will reach there, it will append. So now our stack will have 3. Now does 3 have a left? Do 3 have a left? No, it is not there. It is not there. If it were there, then we have done root dot left and we would have appended this one. But as it is not there, so it will come out of this particular loop. When it will come out of that particular loop, what it does is it will pop. So now 3 will get popped out and appended here. Then we will check if it does have a right subtree. It does not have a right subtree. So our array, like our Inorder array, ends here. Sorry, Inorder list ends here, and this will be our result. So let's code that first. We will take our output, then we will have our stack, then we will give our condition if root stack, then while our root is there, we will append root to stack, then we will iterate it by root dot left. Once we are done, we will come out of that loop. We will pop that element out, the last element, I mean the last node. So we will pop it out, and whichever node we have popped out, we will append it in our result. And after we have appended it, we will check our right subtree. So we are done here. Now we will return our result. Let's run this. Okay. So we have got a type error. Oh, sorry. We will append root value. I wrote result. Now it should work. Yeah, so all the test cases have passed. we will submit it. Yeah, so this is how we would solve this problem by iteration method. So thank you for watching this video. I'll see you in the next one.